Welcome back to my channel Electronic Science Tutorial. Today is the second class of Operational Amplifier. Today I will discuss the different types of input we applied, how we applied into the op-amp, and what will be the output of the op-amp. Okay, so this is the second class of the op-amp. In this class I will discuss the different types of input applied into the op-amp. Okay, so without any time waste, let's start our class. So the first type of applied input, that is the single-ended input. This is the diagram of op-amp circuit, that how we apply single-ended input voltage. This is the basic op-amp circuit where I will see that is this is the input 1, which terminal is called non-inverting input terminal, and this is represented by positive sign, and this is the input 2, which is called inverting input, and this is represented by negative sign, and this is the output of the op-amp. So this is the basic circuit symbol of an op-amp, and this is the two circuit that how we applied single-ended input voltage. When we applied single-ended input operation, or when we occur the single-ended input operation, results that when the input signal is connected to one input, the other input connected to the ground terminal. That means in first circuit, the input voltage is applied to the non-inverting terminal, and so the inverting terminal is connected to the ground terminal. Okay, so this AC signal is applied to the non-inverting terminal. That means non-inverting terminal, in previous class I already talked about this topic, that is when we applied some voltage in non-inverting input terminal, this voltage doesn't change its sign. That means it doesn't invert the voltages. That means if we applied this AC signal to the non-inverting input terminal, we get the same output at the output terminal. Okay. Next, in this circuit, the non-inverting input terminal is connected with the ground, and the AC signal is connect with the inverting input terminal. And when we connect the inverting input terminal, some voltage, when we connect with the inverting input terminal, what will do the inverting terminal? Inverting terminal invert this voltage. That means if we applied positive voltage, we get negative output. If we applied negative voltage, we get positive output. So here we applied this AC signal in this phase, so to the inverting input terminal. So when we get the output, the phase will be changed. Okay, so this is the single-ended input operation. So in the single-ended input operation, results when the input signal is connected to one input with the other input connected to the ground. This figure shows the signals connected to for this operation. The input is applied to the plus terminal, that means non-inverting input terminal, which results in an output having the same polarity as the applied input signal. And this is the figure where we shows an input signal applied to the minus input, that means inverting input, and the output then being opposite in phase to the applied signal. So this is the single-ended input operation. Okay. Next we discuss the double-ended input. In this double-ended input, how we applied the input signal voltage. This is the one type of connection and this is the other type of connection. In the figure A, where we applied a common voltage input to the inverting input and the non-inverting input terminal. Thus, the resulting amplified output in phase we get at the output terminal. This is one type of double-ended input operation. The other type of double-ended input operation, that is individually, if we applied the input signal voltage to the non-inverting terminal and the inverting terminal, what will be the output? The output is the difference of the signal of the non-inverting input terminal and the inverting input terminal. That means V1 minus V2. That means the resultant output is V1 minus V2. That is the difference of the signal voltage, what we applied at the input terminal. So, two types of connection for double-ended input here we saw. One is one common input signal is applied to the non-inverting terminal and the inverting terminal, and the output what we get, the result in phase output, and the amplified in phase output we get. This is the one type of double-ended input operation, and this is the second type of double-ended input operation where we applied individual input signal at the non-inverting terminal and inverting terminal. So, from the output what we get, the difference of the input signal voltage, that is VD. VD means V1 minus V2. So, this is the second type of input signal voltage. Okay. Thank you. Hope you understand today's topic. If you like, share and subscribe my channel.